Hi everyone, welcome to our webinar on artificial intelligence, and this is going to be a really interesting topic today for our discussion. And I've got Dr. Joshua Ho with us to talk about that. He's done some work in a school, and we're going to talk through that today. I've put together some a handout, so you can download the handout, and the handout has some information on the hub about just some lessons and some background if you wanted to get into some more things that we talk about today, and just you can download that handout that we've got. As Joshua is talking, you might have some questions which we'd all love to hear about, so use the question facility on your control panel, and when we have those questions we'll stop Josh and we'll have a bit of a discussion about your questions. So fire them through, because we love to hear about what you've got as a question and to go through that. So artificial intelligence, you've probably heard that term and thought, well, what does it all mean? And today we're going to talk about what it is, the underlying concepts underneath artificial intelligence, and then maybe some just ways you might be able to incorporate it into your classroom. So through talking with Josh, it's very interesting in terms of what is artificial intelligence and where is it going, and what are we doing in the lives today where we're actually experiencing artificial intelligence. So I'll welcome Josh onto the line, and Joshua, and we'll see how we go today. Joshua, talking about artificial intelligence and sharing your knowledge. So thanks for that.
No problem. So hello everyone, thank you for joining today. So I'm just shared my slides. Hopefully you can all see that now.
You can see them?
Okay, good. So so maybe I'll introduce myself. So I am a computer scientist. I work at the Victor Chang Cardiac Research Institute. In my line of work, I develop computer programs to find out why some babies are born with a heart disease, principally by developing a program to scan through a large amount of data in the human genome. So these are genetic data, and we really want to find those small number of genetic defects, such as a mutation, that can cause human disease. And as part of my work, we use a lot of artificial intelligence techniques to help us do that, to in essence identifying why having some mutation would cause disease and predicting what is the consequence of those mutations. So that's kind of why, that's kind of how I use my expertise in my work. So 2 years ago, I have been working with a teacher at the Ravenswood School for Girls in Sydney, and the teacher's name is Matt Skedding. So we have started talking about how we can make computer coding and robotics fun for our students. So we decided we'll try something unusual and something new. So we started putting together some activities and ideas, and I said, well, why don't we try to introduce the idea of artificial intelligence to these year 6 girls. So that's what we did. So we developed a number of classroom activities to try to inspire them to think about AI, think about what AI is, what AI isn't, and why is it so important for them to learn. From my perspective, first of all, I think there are a lot of different things that intrinsically have AI embedded in it in our daily life today. Maybe you can start thinking about what are the daily items that you have that might contain AI. Some examples might include such as virtual personal assistants, such as Siri on your iPhone, Alexa, and other a number of other virtual assistants where you can actually talk to them, can have decent conversation in addition to them answering some of your questions. So it have a lot of AI computer techniques embedded in those systems. Online shopping, there are a lot of advertisements that are quite clever right now. When you purchase something, it will give you great recommendation on what to buy next. And it seems to be able to learn your shopping behavior. That level of learning is a very intelligent behavior, and that's part of AI as well. Customer support. In fact, recently I went to Japan. There are really good robots that can actually go out to meet and greet you. Obviously, you have the body of a robot, but it can speak. Produce human-sounding speech. It's actually quite clever. Movie and music recommendation. Similar idea. Smart home device. There are a lot of systems nowadays, particularly what we call Internet of Things, where a lot of devices are connected via the network. It can learn from your behavior. So actually, before this, I was having a chat with Martin about whether all high technology or modern technology or AI. Actually, no. We only call something AI if it has the ability to learn, particularly learn from experience, learn from behavior. That is, if you deploy a system today, if it behaves, and you get it to run for a few months, and at that point, if the behavior of the system is actually different from when you first deployed it, and in a positive way, that's actually learning. That's actually good behavior that you can attribute to artificial intelligence. On the other hand, if it is just a sophisticated system that performs exactly what's programmed to do, like if you go to a factory, go to where there are a lot of robotic arms, where they always do exactly the same thing. Those are there are a lot of programming that goes into it, but it's not quite artificial intelligence because it's just doing what a programmer tells it to do. It's not learning. It's not doing something sophisticated beyond what the programmer tells us to do. So that's the basic idea there. Other things such as finding a job offer via LinkedIn. Again, it's learning through data. It's actually learning based on the activity, the pattern that it sees online. So that's the kind of AI technology. One of the reasons I'm actually quite passionate about teaching AI to young children is that I really genuinely believe this is a skill for the next generation. So in this picture, this is my daughter. She's now around 18 months old now. So this is a picture taken when she was 4 months old. This is a book about artificial intelligence. I'm not expecting her to learn, but the idea here is that this is a technique that will be, she will see this in everyday life when she grow up. She will be growing up in an age where there's self-driving car, where facial recognition will be very commonplace, where speech recognition will be really, really good, that, you will really just believe you're talking to a human being. So, teaching children nowadays to know how to deal with, to understand this computational technique, and to be not scared, not frightened by this technology. I think this is our job, to make sure they embrace the technology, they learn it, so that when they grow up, they have the skills and the technique to embrace the technology. So currently, I am doing a job. So I'm what we call bioinformatician. So a computer scientist who work with, who deal with biomedical data. My job does not exist when I'm in primary school. I'm actually literally doing a job that did not exist when I was much younger. So, I think it's very likely that some of our school children today will be doing a job that doesn't exist today. So that's why we want to make sure we are teaching them those techniques. So the first question I ask my student is, can a computer think? Or can a man-made machine, like a robot or computer, whatever you want to call it, can they think? Can a non-living matter think? That's actually a really deep question, and this is a question that has been around for many, many years. Philosophically has been around for many years. One of the major breakthrough actually started around 50, 60 years ago, and that's addressed by a very brilliant British mathematician called Alan Turing. He's actually well considered as the father of modern computing. So he came up with a test. It's called the Turing test, to answer this philosophical question of, can a computer think? And the test is as follows. You have an interrogator, that's person C in this picture. You have a person, and he stands in front of a curtain. Behind the curtain, there's two persons. From all intents and purposes, let's just call them persons, but it's actually one human being and one a machine. It's a robot or a computer. Let's say a computer. So, but from the interrogator point of view, he doesn't know which one is a person and which one is a computer. Let's say we can't distinguish the person from a computer based on appearance or this voice or any way. We can only, let's say you can interact and decide based on the answer. So the interrogator can ask any number of questions and any question. You can go from really sophisticated question to just day-to-day, basic conversation. The job of the interrogator is to try to distinguish the machine from the person. You can ask any number of questions, any question, and the machine and the person need to answer it. And the point here is if the interrogator cannot distinguish which one is the computer, which one is the human, then the computer is said to have artificial intelligence, is to achieve that level of artificial intelligence. So this test is actually quite brilliant because it transformed the question, a more philosophical question of what is intelligence, into something that's actually a bit more tangible. What it actually does is to transform this question into asking, well, when can we get the computer to act like a human, to behave like a human, or to mimic human behaviors? That is actually a much more tangible thing. That's something that we can actually work on. And if we frame this question in this way, the artificial intelligence becomes a lot less scary. It's actually not frightening. It's actually just about, programming a computer to behave like a human, to have some aspects of human-like behavior, and that's all that it does. And in fact, in the AI that we deal with in everyday life, that's the kind of AI that we deal with. To have machines that display some human-like quality, or some aspects of human-like quality. Okay, and that's actually when I use those kind of examples for our students, they typically appreciate and they kind of understand that concept. The next part is really just showing them, well, computers is there, they all come in all shapes and sizes. They can look like a computer, but they're everywhere. In your phone. In early days, the computers is in a very big machine. They come in, if you fly a plane, the computer is actually controlling the plane. You have, robotic device like the Lego Mindstorm system, or artificial limbs. They have a lot of computer programming inside them. But regardless of what the physical hardware looks like, it all comes down to computer programs. And computer programs is really just a set of step-by-step instruction that converts a set of input to a set of output, and that's all that it's doing. It's a recipe. It's like cooking. It's converting a set of ingredient through a recipe. You get your meal out of that, and that's the basic concept. So if you want to program an AI program for robot, it's all the same. It's just a recipe, and you can do that. The key concept here is, even in Turing's day, he doesn't have a computer. At that day, there's no such hardware called computer, but he can imagine what a computer looks like. It turns out the basic concept of a machine, which he called a Turing machine, is, now obviously we have a physical manifestation of that, which we call computer. At that time, he doesn't have that, but he can imagine what a computer looks like, and that's a Turing machine. the really basic concept of a Turing machine is you need a place to store data, and that's what we call a variable, or some form of variables in a computer programming language. You need some form of decision making or branching, and it's a switch or an if-else statement or branching in various form of programming language. And the third is you need a way to repeat your process, and that's a loop. So essentially, modern programming language is actually not that different from what Alan Turing have came up with at that time. If you have some way of storing data, some way of branching a program, or switching, or have some form of if-else statements, and a way to loop, a way to repeat your process, that's all you need. Even if you want to build, AI system, that's all you need. Okay, now the next bit is, so here I'm going to share 2 different activities that I actually did with the students. So these are year 6 students in a girls' school, and we did 2 different activities. So this is the first class where we did facial recognition. So it's a task of how modern system can recognize faces and associate that face with a name. And formally, we try to frame the system, the problem as, you get an input. An input is a picture or photo of a person, and then output is the name of the person in the photo. Okay, and that seems like a very difficult task. Many people nowadays, in fact, even year 6 students, have a very intuitive understanding of what facial recognition system looks like. If you go through border patrol at airport, they might have seen how system take pictures of individual people. Even iPhone 10 has a system to use facial recognition as a password to log into a system. So actually, our students nowadays have a very good understanding of what facial recognition looks like. For many of them, they think it's a very difficult task. And this exercise is, we want to do 2 things. One is to make them understand that doing facial recognition or AI is actually not scary at all. It's actually very simple. The basic idea is actually very simple. And the other idea is to get them to really try to understand how to break a seemingly difficult problem into a set of smaller problem and to build an algorithm to solve that. So I want to first explain why facial recognition seems to be difficult. The difficult part seems to be that, well, the same person actually moved. They have different, they look differently in different photos. Again, this is my daughter, and these are her photos. She looks the same to you because you're human. You're very good at doing this. But for computers, it's actually very hard. If you do a simple thing like getting 2 pictures, overlap them, and try to match pixel by pixel, well, then you'll conclude that, well, none of this is the same. Well, of course they are not the same, but the content in the photo is the same, the person in the photo is the same. We can recognize that they are the same person because we recognize facial feature or the feature of the person. Things like hair color, hair length, eye color, clothing, and so on. So these are things that we can recognize. This is, again, AI is about mimicking human behavior. And this is what human does. We try to extract some feature, quantifiable feature, and really try to say, well, now this is a human in front of me, there's an image in front of me, I'll try to match those features based on my experience to what I understand as that person. Okay, so the exercise that we did with our girls, this is essentially matching a photo of Disney princesses. It's good in 2 reasons. One, in a girls' school, this works really well. They all know their princesses. So that works well. And the other thing here is that Disney princesses, they always wear the same clothes. So it's actually very good in that sense. They're easily recognizable. The Disney princesses always wear the same clothes. So it's very helpful for me to come up with feature for this exercise. So the idea here is to do facial recognition, we need a database. We need a big database of many photos and the name associated with the persons in the photo. So that's the task. And when you have a new photo without the name, can we match and give a name to that photo, the new photo? Okay, and what we want them to do is to, let's say we give them a set of photos. We want them to extract a set of features like dress color, whether it's long hair or not, dark hair color or not, dark skin color or not, whether this person is holding something. They need to first write them down to convert the content of the feature in the image into a set of features. Okay, then when you have a new photo, you can do the same. You can list the features, and then we can get them to match the number of features that are identical to each of the individual photos in the database. So in this case, Snow White get a similarity of score of 2, Belle get a score of 1, and Jasmine get a score of 4. And in this case, it's the correct answer, Jasmine. Even in this case, I get them to think about, well, actually, even in the correct answer, Jasmine, out of 5 answers, only 4 was the same. And that's the whole point, because, well, the person can move, different gesture, maybe even different clothing. In this case, whether they're holding something or not. That is changing, and that's why you need a large number of features. You want good features. You don't want an irrelevant feature. You want relevant, useful feature. So I proceeded to getting 7 students to come up to the class. So we selected 7 students randomly. We get 6 students to be the database, where they take photos and a name associated with the princesses and get them to fill in this form. This image feature list, and we also get 1 more student to also take a photo of a princess without the name and also fill in this feature. At the beginning of the exercise, we get the girls to just fill in this form without showing the photo to the class. So that at that point, the class really have no idea what that is. And then I get the student with the new photo go through the other 6 classmates one by one to compare the answers and give a score based on how many of the answers are the same. So she'll go through her classmate one by one to give a score, and I ask them to pick the one with the highest score. Then I'll get them all to reveal their photos to the class, and at that point I'll ask whether the answer was correct or not. I've seen most of the time the answer is correct. They can get the answers right. There are some small number of cases they got it wrong because the students didn't answer didn't answer the question correctly. Well, even in that case, you can still learn something, because I can tell them, well, you didn't get that right because, well, you'll get some of the answers actually not correct. Might be you didn't get the hair color right, or you didn't get the length of the hair right. And that highlights the point of, getting good quality data and getting good features extraction is important. Okay. And the other thing we want to teach them is, well, actually, in this case, you have 6 princesses in the database. Well, maybe if your database is smaller, like just 3, and your actual princess is not in this database, then you will never find it. You will never get an accurate, correct answer. And that's one important point. For machine or for artificial intelligence to work, you need data. You need a lot of good quality data. And that's another word that it's the buzzword nowadays called big data. You need a lot of data. And that's why big data and artificial intelligence actually go hands in hands. If you don't get good quality data to train, you don't actually get good quality artificial intelligence. So at this point in this lesson, the summary for this is artificial intelligence is not scary. It's really getting a program to simulate some aspects of human-like behavior. We try to look like what human looks like, what behavior and so on. And the second bit specific to facial recognition is, well, you can convert a big problem like, matching photos to a simpler problem such as matching feature from a photo. Obviously, the part about converting the photo into a set of feature is still actually quite difficult for a computer to do. That's actually a whole lot of whole different computer vision issue, and that's why I made it into not a programming exercise, more a game for my students. But for a human, we can do feature extraction quite easily, and let's just keep it at that point. We can do feature extraction. If we can extract feature quite well, you can then do facial recognition very well. And the third point is you need big database to get accurate facial recognition. And at this point, this is where we can, kind of highlight some of the issues about this. For example, this is kind of the reason why when you go through border security, our government wants to take our photo, because these photos is very useful. The photo with your face and your name from your passport actually is very useful information. It becomes part of the database and can be useful for subsequent facial recognition information. And that's why some company, when you join, they need your photo. Some company use it for this kind of purposes. But in any case, good data is important. Keeping and so therefore your photo, regardless of whether deliberately you put online or sometimes you put accidentally online, such as on Facebook, Instagram, or social media site, those are actually information that can be useful in many different ways, such as those facial recognition system or many other AI system. So if we want to teach our children about data security and so on, this is actually a good point to also highlight those facts.
Yep, Josh, I was just going to mention then in the curriculum we sort of talk about there's obviously innovation with something like AI, which everyone gets really excited about what we can do. There's also some of those risks, and you're just touching on the fact of the privacy issues and the use of the data and what actually happens to it. So I think in some courts there is some concern about what happens with that data, and just being mindful of having that discussion with students. But in terms of the curriculum, if you go through our curriculum, you won't see the word artificial intelligence. But I think where Josh was pointing out now is that in this section we're looking at data, obviously, and it sort of fits into all areas of the curriculum for across, say, F to 10. And so if you are trying to look at doing some artificial intelligence lessons, the knowledge there that Josh was passing on there is really sort of connecting with the data. There was data representation in terms of those princesses, and it's probably thinking about activities like that and Josh is sort of picking up the what's the underpinning concepts that he was trying to get across there. So Josh, have you got any other sort of lessons like that facial recognition that uses data, or what other things that teachers might be able to do in the same sort of area?
Well, mainly, this is, the next exercise also has some of that as well, and where data and feedback from human is very, very important. So we'll touch on that. And most of my other ones, this is the most direct one that I have, that talks about the importance of data and how big data can be used. I don't have any.
On the spot. It's okay. Let's get into the next bit. But yeah, it's really interesting, and looking forward to seeing what you're talking about next.
That's right. Suppose when we go to the next part, it will also make more sense anyway. So the next part is about learning. But more importantly, can a computer, can a robot learn? Learning is a very human behavior, or higher organism, we learn. And that's actually really important. So, and that's, fits squarely into the area of artificial intelligence, because learning is kind of very key aspects of intelligence. Okay, so again, this is an example from my own daughter. She's, a year and a half, and she have learned a lot of new skills. And this is actually a very good example of how human learns. And I think one aspect of learning is trial and error. Humans do that a lot. We learn by taking an action, maybe failing, and therefore feedback. You get a feedback from that, and you repeat. For example, when I teach my daughter to feed herself, grabbing onto a spoon, moving her hand close to her mouth and eating, that is not easy at all. This is actually very difficult. She has to try and fail, but each time when she is not successful, this is actually part of the learning process. Taking an action, obtaining feedback, repeating, and eventually she learns, she can do it. This is actually not that different from the machine, at least one major machine learning technique, which we call reinforcement learning. But just ignore the name. It's actually trial and error. It's actually that simple. So the picture you see here is a robotic arm that's tied to a pan, and there's a fake pancake on it. It's a YouTube video that I downloaded, essentially, that show how a team of scientists try to get a robotic arm to learn how to flip a pancake. What you see is initially you get a human holding onto the robotic arm to try to teach it to learn the basic motion of flipping a pancake. Then after that, the robotic arm will try to do that itself. First 50 times it's doing terribly badly. It doesn't, it can't flip a pancake. Sometimes it's too, not enough force. Sometimes, big motion and the pancake go, a few meters away. So, but the idea is, it keeps learning, try and error, and every time it learns a little bit. It learns from failure. It learns, okay, doing that, it's too much force, or doing that, the angle is not right. Maybe I'll adjust that. So it's that process of fine-tuning. The other way to say that, it's about reducing the search space. It's about minimizing the variability, minimizing the space, until you can do this motion very, very well. So whenever I show this to my students, they're always very happy, because it is actually quite an amazing process to see a robotic arm learn how to flip a pancake. Again, getting a robot to display human-like behavior. That's the essence of artificial intelligence. Then I went on to introduce a game. It's a very simple game. On the surface, it might not look like what we call machine learning, but bear with me, because it actually is illustrating a very important aspects of machine learning. Okay, this game is called a number guessing game. The idea here is that it's a two-player game. One player, let's call the human, think of a number between 1 and 100, a whole number between 1 and 100. Then the second player is a robot. The robot needs to guess a number repeatedly. Can keep trying to guess a number. Let's say I'm thinking of a number of 70. Let's say the robot guessed 30. Okay, and then you as a human need to respond by saying whether the guess was correct, whether it was too high or too low. So you give feedback. The goal for the robot is to give the correct guess in the minimum number of guesses. Okay, guess the right number in the smallest number of iterations or rounds. Okay, so let's think about this game. This game is really about for the robot to get to the right answer. There are a number of different strategies, and you can easily see some strategies are quite dumb, really not very clever, or what we would consider quite clever, and some strategies are more clever. The first one is that every single round you just randomly pick a number between 1 and 100, regardless of the feedback from the previous round. Okay, so every round the robot will just make a guess, regardless of what was the answer from the previous round. As you can see, the robot will eventually get the right answer, but you'll probably agree that this is not a very effective way to do it. The second run is that you start from 1 and then go 2, 3, 4, systematically going through that till you reach the right number, because there's a finite number of whole number between 1 and 100. You eventually guess it. Again, This is actually not a very efficient way to get it. And most of my year 6 students can see that these two are not very effective strategy. The third strategy is that, well, after the first round of random guessing, you make use of the information from the human response to produce the next, and to help you reduce the range of possible values for your subsequent guess. That is, let's say, for example, first round you guess, 46, and the answer was too high, then your next guess needs to be between 1 and 45, because it's not going to be 46, it's not going to be higher than 46. So next round, your range of value will be smaller, and next round will be even smaller, and the next round will be even smaller. And most people in my class can see that, well, this is actually a much better way, much better game strategy. And then the idea here is that, well, actually, this is learning. Your robot is learning previous unsuccessful guess, but the unsuccessful guess, the failure, become useful information that allows you to come up with better guess. And after a few rounds, you actually acquire quite a bit of information to give the right answer. And that, in essence, is learning by trial and error. Actually, when I was discussing with Martin, he pointed out that, well, actually, this is actually the third option is somewhat similar to the binary search, which is a technique and an algorithm that's commonly used and taught to students. Yes, well, the idea is very similar to binary search. In fact, binary search will actually give you theoretically the best possible result, because you always bisect the range and you find a good result. But to our students, the third strategy will perform, similarly well. The whole idea here is to get them to think about, what learning means. So in the school that I go to, they were using the Lego Mindstorm system as a teaching tool. So in this case, in my class, I actually get them to build this number guessing game. As in, I actually want them to program the robot to actually play this game. So they can experience it. So I give them this code, and obviously for different schools, different classes who have different system, this may or may not be helpful for you. But the idea here is why I show you this anyway, is to highlight that, well, this program makes use of mainly 3 different main programming blocks: a variable, a switch, which some people call if-else statement, or branching a mechanism, and a loop. Just these 3 things: variable, switch, and loop. And I keep highlighting that is because, well, if you have all these 3 tools, you can do any program, even a program that can help you play game, and a robot that can, learn. It's actually just these 3 things that you need. And I think in all my classes, I'll keep repeating that. Well, you can build very complicated things by using these 3 things really, really well. Okay, and these are just some of the actual code that we have. The next week after the initial lessons, the number guessing game, then I do something a little bit more interesting, and I want to get them to program a lawn bowling robot. Well, first of all, I show them what is lawn bowling, just in case some of them don't know. Why lawn bowling is an excellent exercise, is a good activity, is because the game of lawn bowling is about accuracy. The whole goal is about accuracy. It's not about the fastest, not about the furthest or the strongest, the hardest. It's about the most accurate. You can't bowl the ball with too much force so they go too far, but not too close either. It's about accuracy. This lawn bowling exercise, or the process of training a lawn bowling robot, is actually somewhat similar. In fact, it's exactly the same as the number guessing game. So that in that lesson, what I did was, well, first of all, we need to build the robot. And again, because they have a Lego system, I get them to build a robotic arm to attach to the main body. And then the code down there is really just, code to make the robotic arm swing. The key parameter in that, in that code is the amount of force it takes to swing, or the speed for swinging the robotic arm. And that's the key parameter for the machine learning component. So what essentially after you have built that robotic arm, the actual source code for building a learning lawn bowling robot is actually exactly the same as the one here for the number guessing game, except we take out the part where the robot display the number on the screen. What it does, it takes the number, put it into the code here to assign as the speed for the force for swinging arm, and then you can build this robot, and then it can learn. So in this robot, what it does is, first of all, in the first round, it just randomly select a speed and then swing the arm, okay? And you as the human can look at the results and see, oh, actually, the ball is too far away. Give that feedback to the robot, saying too far or not far enough, okay? Okay, if it is too far, then you should swing the arm with less force. If it is not far enough, then you need to swing the arm with larger amount of force, okay? So you keep doing this for a few rounds, and then the robot should settle down to a force that is actually just about right. At that point, what I did was I get the students to group into, a group of 2 or 3 students in the robot. I get them to train the robot, and then we get them to play a game of lawn bowling. It's a fantastic exercise, and and the idea is, and they're very competitive as well. They can, they have fun really trying to get the robot to, and they really spend time training the robot so that they get the amount of force just right. So the students appreciated that lesson quite a lot, and they have quite a lot of fun with that. So at the end of that, the summary here is, again, AI is not scary. An AI program simply simulates some aspects of human-like behaviors. In this machine learning class activity, what we're doing here is to get them to really think about learning, which seems to be a big word, into a process of trial and error, which they can understand as, repeatedly trying things and improving a little bit at a time. And also big data is also relevant here. Again, to get accurate performance or good performance, you need to give good training data. That is, when you give feedback to your lawn bowling system or get feedback to the number guessing game, you should give them correct feedback. Sometimes if you do not give the correct feedback, then the system can go wrong very quickly. It doesn't learn, it will perform terribly, badly. Like the number guessing game, if instead of saying too high, you say too low, well, then you never get the right answer. Perform very badly. And that is actually in a different way, the importance, it highlights the importance of big data. Good, accurate, reliable data. And if you get that, you get a good machine learning system. All right, I think that's the end of my presentation. I'm more than happy to take any questions from anyone.
Good one, Josh. That was really exciting and really interesting the way you structured that for us in terms of making it. I think you really got a head there and demystified artificial intelligence, because I think that's the way you came back and just talking about that machine learning and basically how it's those examples really sort of structured and gave us that idea. I think was very useful. So thanks for doing that. One of the questions Sue Carter had was, you did that with the year 5, 6 or year 6 students.
I did it with the odd activities with year 6.
Yep.
This in this school, the girls have been doing various kind of robotics and computer programming throughout their primary education. So by the time when they're in year 6, they kind of know a little bit of programming and robotic already. So so that's why we're happy to give them something a little bit more challenging like this. But yeah, my own experience here is year 6.
I mean, when I look at that activity, I can see year 7 and 8 kids doing that.
Yes.
That sort of concept, and actually with the programming. And we had a discussion offline about, if you've got a line following robot, which a lot of teachers sort of would be doing that with the Lego Mindstorm. And we had a discussion about, what's the difference with if you've got a line following robot, which uses that sensor to pick up the black and white reflective light. How is that different to artificial intelligence? And if you could just talk through what we had a discussion about.
So the idea here is, a particular, the use of sensor or some kind of feedback mechanism does not necessarily automatically make it artificial intelligence. I think one key aspect of that is about learning. It's about getting feedback. That means, I think the test is when you have deployed a system one day, like get it to drive or get it to run on one day and get it to do all that. And if you do it and stop it and then you run it again, would it improve the performance? Would it do any better? Or would it always do exactly the same thing, exactly what you programmed it to do? If it's just exactly following the program, it's not quite artificial intelligence. It's just a well-programmed robot. That's it. You can have a well-programmed robot like those in in a factory. There are many robotic arms. In a car factory, for example, those robotic arms are well-programmed. They do amazing things, but you do not call them AI. They're just robots. True AI, or at least in a more meaningful sense, is when it learns something based on feedback and data. For example, if you build a system that follows line, but instead of explicitly giving a rule saying, okay, if it is closer than 5 centimeters or further away than 6 centimeters, then you will do certain action. If you do not give that parameter and you get it to learn that parameter by providing feedback, then that would be learning, and that would be an AI. But in terms of the coding, it's actually not that difference. It's actually just a minor change, and you can kind of make an AI system. So I think that's the main difference.
I think that's it's a really useful point to make, and if teachers are incorporating this programming, keeping aware of that. So, for example, a lot of teachers would have a Sphero robot, for example, and they might make a maze, and then you might sort of code that Sphero to move through that maze. Now, obviously, it's just following a program, a recipe. But then if you add your sensor and try and avoid collisions, you can, as you were talking about then, if you had those parameters, can you just talk through that then? If you had sort of a Sphero robot, for example, and how would you make that AI based?
Yeah, I mean, the whole idea is similar to the lawn bowling robot. So, I mean, you can actually build a very simple lawn bowling robot by specifying the value. Okay, so let's say optimally, you can say, well, swing the arm for 50 degrees at this speed. You will always do it well. The thing here is that it doesn't learn. There's no feedback. So what you need to put that into a loop where you can, and then you can, in some kind of, maybe it's some kind of random number generation system, or some way like a binary search kind of mechanism, so that it will learn. Okay, it will create a number for this, create a speed for swinging arm, actually performing the action and somewhere feeding back that information in, and then it will learn. So in the case of, say, the line following driving robot, what you need to do, so instead of specifying, well, if it is if the distance between the line or a robot to avoid collision, instead of saying, well, if it is the distance is is less than 5 centimeters, then you stop or you turn or something. You don't give that parameter, you do not give that value, but you get it to learn. So that means you randomly generate a number, you try, but let's say if it collides, then you give feedback and say, well, actually that's not good. And it's trying to adjust that value and then iteratively learn.
I mean, I find that really fascinating.
Yes,
I'd love to see that. I might try it and to see how it works. But definitely, that would, with the students, that would make it really interesting in terms of using Aspiro to incorporate that artificial intelligence. We did have a question from Matthew Bliss, but it's a question about whether have you worked at all to structure digital technologies and artificial intelligence together in secondary to build towards algorithmics in year 12? Now, that's a sort of pretty high level question, and a lot of the work we're doing at the moment is obviously just structuring, where does it fit in the F2 curriculum, but essentially, what will lead this information on for students will be having a grounding of knowing what artificial intelligence is, using those sort of concepts that Joshua has been talking us through. Obviously that'll feed into those higher levels, but we haven't really made that connection just yet. But it's a good question. Thanks, Matthew. On my screen, I've just got the downloaded version of the webinar handout, and I just wanted to flip through some of those things just to sort of say what's there. Joshua mentioned the Turing test. So in the field guide for artificial intelligence, it goes through that in a bit more detail. If you're interested in that, that field guide's a really excellent resource if you want to skill yourself up a bit more about what is artificial intelligence. It goes through some of the things, the game that Joshua was talking about. Again, there's some more in CS Unplugged, some more artificial intelligence type activities you can do unplugged. That searching algorithm, I just thought I'd put that in there. If you're doing years 3 to 4 or 5 and 6, that Battleships game uses a similar sort of function in terms of trying to work out, it's a search algorithm. So it's just the early points of getting into artificial intelligence. Divide and conquer, same thing, that binary search. So it's just some things you can do leading up to artificial intelligence. Joshua's 2 activities there, machine learning and facial recognition, are on the DT Hub, and you can go through those and you can make the connection between the webinar and those activities that Joshua was talking about. The introduction to artificial intelligence, I'll put that in there because there's quite a good slideshow that was produced, and you might find that quite interesting to share with your students. There's a little bit of an intro to artificial intelligence. Again, it's got some cross ideas that were mentioned tonight. And also robotics and embedded systems, year 9 and 10. There's a scope and sequence there, and we do have some of those lessons talking about artificial intelligence in a small sort of way. But the guessing game, if you're interested in year 7 and to 10 and you wanted to get your students to either program this, maybe with Python or with Java, one of the different sort of programming languages, or you could just do it as an algorithm, writing that out, the guessing game. But there's a good activity there that students can use the interactive there to go through and, out of 300 numbers, forcing the robot to select that in 9 guesses, which it's quite easy to do if you use that binary type search. The chatbot, Blockly and Python, are both like a, introductory how to write a chatbot sort of type program. So that, it's either in Blockly or Python. So I'd suggest to have a bit of a look at that. But essentially, you've got a lot of resources there on the hub. You've got Joshua's great insight into sharing what he knows about artificial intelligence. So hopefully you enjoyed it, and we'll see you next time. Our next webinar is on BBC Microbit and how to program that, and just to get started with your students. So if you haven't had a look at the BBC Microbit, have a look before the webinar, and then we'll go through and we're going to show you how to program it online. So it should be a whole lot of fun. And thanks, Joshua. Really appreciated your insight into what is a fascinating area, and I think you really did demystify artificial intelligence for everyone, so I really thank you for that.
You're welcome.
Okay, good night everyone, thank you.